guys, welcome to a most exciting video on absolute value functions. Your I can statement here is I can graph and write absolute value functions. The absolute value of a real number, according to our board here, can be defined into two different equations. X can be a positive, or X can be a negative, or even 0, so technically 3. Don't let this bracket fool you. It's just showing you how X can be split into these different definitions for the domain. So different values X can be. An absolute value function is a function that requires you to put many different values in for X. So this is the definition there. The big thing I want you guys to remember for this is the graph of an absolute value is a V. Okay, so here is some stuff about the parent function of an absolute value function, the parent graph, excuse me. The parent function, all of the other absolute value functions come from this, the definition of an absolute value of X. That means, remember, just a refresher, if I put a negative into that absolute value sign, the answer for the absolute value of, let's say, negative 2 gives me 2. It takes the positive. The absolute value of 2 is also 2. It also takes the positive. The graph of a function like this is going to be V-shaped because, as you can see, you cannot put a negative in there and end up with a negative. You'll always get a positive. The vertex of your parent function is at 0, 0. You can see it's V-shaped. And it's symmetric about the y-axis. Now these are specific characteristics for the parent function only. This can change when we have transformations or translations on our graph. Just remember a little tip here, for every xy point, there's going to be a negative xy. Okay, as I said, we are going to be doing transformations and translations on this graph. What that says is we'll have a specific equation that shows us any shifts or changes in the size, shape, or position. Please write these two definitions down in your notes. The transformation changes the graph's size, shape, position, and orientation. So it can completely change your whole graph. It deals with any of the different changes we might do. A translation is only the left, right, up, down movement. It does not change the shape, so no stretches or reflections. Okay, now here's where we're going to start doing some stuff with it. We want to graph this function up here. You can see it's a little different than our parent function. First step is we want to identify and plot that vertex. And you know what's really cool is I'm going to look in the same spot as vertex form of a parabola to find this vertex. My x value is going to be whatever's next to x. And I'm still going to pull out the opposite. It says x plus 4, but my vertex, my x value, or my h, is going to be a negative 4. We pull out the opposite. Then, whatever's at the end is your k value. So we have a vertex at negative 4, negative 2. That's my vertex. Step 2 says plot another point on the graph. Use symmetry to plot the other point. So if I picked, let's pick negative 2. If I put negative 2 into my function for x to figure out a y, negative 2 plus 4 is 2. The absolute value of 2 is 2. 2 minus 2 is 0. So if I plug in a negative 2, I'm going to get 0. And you know what? Again, is really cool. Absolute value is also symmetric. So that vertex also becomes an axis of symmetry, just like parabolas. So I can reflect over this other point. This point is 2 spaces away from my axis of symmetry, so the other one is also 2 spaces. Then I'm going to make the V shape. A lot of people confuse 4 is 2. The absolute value of 2 is 2. 2 minus 2 is 0. So if I plug in a negative 2, I'm going to get 0. And you know what, again, is really cool. Absolute value is also symmetric. So that vertex also becomes an axis of symmetry, just like parabolas. So I can reflect over this other point. This point is 2 spaces away from my axis of symmetry, so the other one is also 2 spaces. Then I'm going to make the V shape. A lot of people confuse this with parabolas, and I see U's. No U's, always going to be V's. And if we draw in our parent function of an absolute value graph in red here, we can see that our graph shifted 4 units to the left and 2 down. So we shifted 4 units left and 2 down. That's what they're looking for when they ask you to compare the graph with the parent function.
Could a custodian please report to the gym? Custodian to the gym, please.